Hello class, welcome to the review of the 8.2 SOHCAHTOA worksheets. We're going to start here with number 4. I figured these first three, 1, 2, and 3, should be pretty easy for you. If not, you need to go back and review the notes video for 8.1 and 8.2. Number 4 says, using the triangle ABC above, what is the sine of angle A? First question, what's the sine of angle A? They are not asking for the measurement of angle A, they are asking for the sine of angle A, which means the sine ratio of angle A. You can see, and it's even little cheat sheets right here for you, right? Sine, SOH, stands for sine is equal to opposite over hypotenuse. So if I go up to angle A, that's right up here, this 60-degree angle. The side that is opposite is 10.392. Okay, so first we're going to write opposite over hypotenuse. And then we're going to write the opposite side is 10.392. And then the hypotenuse is always across from the right angle, that is 12. And then we're going to divide that to get it a more exact decimal ratio there. So we're going to see 10.392 divided by 12, and we get 0.866. So we're going to write 0.866. And that's all we're doing here. Okay, so the next one says, what is the cosine of angle A? So we're still looking at that same angle up here, except cosine is adjacent over hypotenuse. So we want to write A over H. The adjacent side to angle A is 6. It's right next to it. And the hypotenuse is still 12. 6 over 12 is 0.5, or 1/2. Next one, what's the tangent of angle A? So we're still using angle A. Let's clean that up a little bit. Still looking at angle A, except tangent is opposite over adjacent. Opposite to angle A, 10.392. Adjacent to angle A, 6. So we want to say 10.392 divided by 6. Let's see what that is. 1.732. Finally, next question is what's the sine of angle B? So let's go find angle B. We can see angle B is this angle right here, down here, the other acute angle. Sine is opposite over hypotenuse, opposite over hypotenuse. The opposite side to angle B is 6. The hypotenuse is 12. 6 over 12, which again is 0.5. I want you to see that the cosine of one acute angle, as you can see, is equal to the sine of the other acute angle, cosine, because the only difference is opposite and adjacent, right? Well, they switch based on the acute angle in which we are referencing. So now the table is here. It says now find the following trig ratio using your calculators or the trig tables. We can just use a calculator because we all have a calculator. It says round to 3 decimal places. So it says sine of angle A looking at this table, it wants us to find the sine of angle A. Angle A, as you can see in the diagram, is 60 degrees. So I'm going to replace angle A with 60 degrees. And we can replace it here and here. And then the last one, it says sine of angle B. Well, angle B is going to be 30 degrees, right? Because that's 90 plus 60 is 150. Subtract that from 180, and you have 30 degrees, right? So angle B is 30 degrees. So we're going to find the sine of 30 degrees there, and then we're just going to punch this in our calculator. That's all it's asking us to do. So let's move that over. Let's check it out. So 60 degrees, sine, look at that, 0.866. I'll just remember that. Cosine, let me clear that. So this is 0.866. And then we find cosine of 60 degrees. That's 0.5. Then we find the tangent of 60 degrees. So 60 degrees, tangent, 1.732. And finally, the sine of angle B. And remember, angle B is 30 degrees. So the sine of 30 degrees, 0.5. And notice how these are going to match up with what we just looked at above, right? The sine of angle A, see, 0.866. So notice how the sine of 60 degrees is equal to that ratio. It's just dividing the sides, right? This one matches. So cosine 60 is the same as adjacent over hypotenuse, 1.732. Notice how that's the same. And finally, the sine of 30 degrees, angle B, and that's the same as well. So we're getting you to see that these ratios are simply, for example, anytime you have a 60-degree angle in a right triangle, the ratio of the opposite side divided by the hypotenuse, which is the sine ratio, will always be 0.866. So that's hopefully what we're getting you guys to connect and realize there, that type of problem. Let's do a couple of these over here. Number 6, let's look at these. So number 6, it says, what is the length of side AB? So I'm going to label that side X. We're going to use 68 degrees as our reference angle. So that's what it's asking right here in B. The reference angle is 68 degrees. That's the angle we're using. So I want you to skip this A part. We're not going to use that. C says, I know. Well, what is it that we know in the figure? We know AC. So AC is opposite that 68 degrees. So I'm going to write, I know the opposite side. I want to know, well, we want to know the hypotenuse, right? So I want to know the hypotenuse. Okay, so if we know the opposite and we want to know the hypotenuse, we're going to use sine, right? Because sine is what? Opposite over hypotenuse, right? So use sine ratio, SIN for short. So the equation is sine of any angle theta is equal to the opposite side of that angle divided by the hypotenuse. Okay, so 68 degrees is our reference angle. That's going to be substituted for angle theta. The opposite side is 27, and then we're solving for the hypotenuse, right, which is x. So let's go ahead and plug those values in. So we're going to say the sine of angle theta, which is 68 degrees, is equal to the opposite side, 27, over the hypotenuse, which is x. And now we're going to convert sine 68. So we just punch that into our calculator to see what that ratio is. And we can see, and this is where I want you to go to 5 decimal spots. So 92718 is good enough. So we're going to say 0.92718 is equal to 27 over x. Remember, we can put that decimal ratio over 1, and then we're going to solve this by cross multiplying. So 1 times 27 is equal to 0.92718 times x. So 0.92718 times x is equal to 27 times 1, which is 27. And we're going to divide both sides by that decimal number. And that's going to give us our answer, 92718. There we go. So then we're going to say AB, that's what we're solving for, is approximately, let's punch that in our calculator, 27 divided by 0.92718. And we get 29.1. So AB is approximately 29.1 inches. I'll leave number 7 for you guys to look at and figure that out. Same exact idea. Let's look at number 8. So number 8 says, I told you guys we can skip this A part. What's our reference angle that we're using? We are using this 56-degree acute angle right there. That's our reference angle. What do we know? we know, what did they give us? They gave us 25, right? So what is that? That is the adjacent side to that angle, right? So we know the adjacent side, and we want to know, well, up here it says what's the length of NP, right? So we're going to label that X. So we want to know the opposite side. So that's the opposite side. So notice how the hypotenuse is not even being used in this problem. So you should be saying the tangent ratio is opposite and adjacent. So we can say that the tangent of angle theta is equal to opposite divided by the adjacent. So we're going to say that tangent theta, which is 56 degrees, that's our reference angle. So will always be equal to the opposite side, which is x, over the adjacent side, which is 25. So x over 25. So every 56-degree angle, right, in a right triangle, the tangent ratio is always going to be some number divided by 25. So what we do is we figure out, well, what is the tangent ratio of 56 degrees? So we punch that into our calculator, 56 tangent, and we see that it is 1.48256. So we're going to replace that, 1.48256, 5 decimal spots, is equal to x over 25. And we're going to put this decimal over 1. We're going to cross multiply and solve. So 1 times x is x. That's NP. So I'm just going to replace it back with NP now. That's what we're solving for. Is equal to the other cross product, 25 times that value. So we're just going to multiply that by 25. And we should be getting 37.1, right, if we round it to the 10th place. So we're going to say NP is approximately 37.1 centimeters. So that one we had to use the tangent ratio because we were dealing with the opposite and the adjacent side of the right triangle. So that's a couple. The rest of them are pretty similar. I think the hardest thing you guys need to realize or practice at is decide whether to use sine, cosine, or tangent ratio. So you want to decide that based on the angle you're using and the information that's given to you. So like for example on number 7, we're using this 21-degree angle. They're asking us to solve for GK, so we're going to label that X. Notice how that is the adjacent side to that angle. Notice how, what did they give us? They gave us 16, which is the hypotenuse. So we know the hypotenuse. We want to know the adjacent side. So what trig ratio uses adjacent and hypotenuse? You should be thinking cosine. So that means you want to use the cosine ratio right here to solve this. So you would say the cosine of 21 degrees is equal to the adjacent side, x, divided by the hypotenuse, 16. And then you should be working that out and solving that from there. So hopefully that helps a little bit more.